Hello, today I am going to create a program that solves the logic module from the game Keep Talking and Nobody Explodes. But first let's see how we solve the module. This module does require edge work, meaning the parts that are on the side of the bomb are required for us to solve it. So let's go over what we have. A parallel port. A serial port. 2 RCA ports. 2 PS/2 ports. A DVI-D port. 1 RJ45 port. Another DVI-D and PS/2 port. A battery holder that has 2 AA batteries. And a serial number of 5K1NE2. Now, let's see how the module looks. We see a yellow submit button, 2 green buttons with the letter T, and 6 letters with 3 of them having red dashes above them. We can toggle the green T to make them a red F. Let's go over the top line. Here we can see an I, X, and S and symbols between each letter. How are we supposed to know what the letters and symbols mean? Let's go over the manual to see. Here we can see what statement each letter represents. We can see that they're all true or false statements that correspond to the edge work on the bomb. If we look back to the letters we had, I, X and S. I says the last digit of the serial number is odd. Well, if we look back at our serial number we can see that the last number is 2, which is even. This means that I is false. Let's look at X's statement. It says there is exactly one indicator. Since we don't have any indicators, this one is false too. The S statement says the sum of the digits in the serial number is greater than 10. Let's look at all the digits of the serial number. We have 5, 1, and 2. This adds up to 8, which is less than 10. So S is false too. But what about the red dash? That is supposed to represent a not statement. Which means the letter it's above is the opposite expression. So instead of I being false it's now true. Now that we have identified the expressions for each letter, we need to put them together. That's where the symbols come in. Each one represents a logic gate. The first one represents the AND function where both statements need to be true for the expression to be true. Otherwise it's false. The second one is the OR function where one or both statements can be true for the expression to be true. Next is the Xor Gate, which is also known as the exclusive OR gate. Only one of the statements can be true, or the entire expression is false. Next is the NOT AND gate, also known as the Nand Gate. It's the same as the AND gate, but the opposite. Meaning if both statements are true, then the expression will be false. Otherwise it's true. The same can be said with the NOT OR and NOT exclusive OR gates, which are commonly called NOR and XNOR gates respectively. The NOR gate is true when neither expression is true, while the XNOR gate is true when both expressions are true or false. Finally, we have the most complicated logical gates, implication. For the sake of time, and my sanity, let's just say A implying B is the same as saying not A or B. And B implying A is the same as saying not B or A. If you want to learn more about implication statements, I recommend checking out Stack Overflow. It's a good website for anything related to coding and or logic. Anyway, now that we understand what each symbol means, let's get back to our expression. But wait! There's 3 letters. How are we supposed to know where to start? Well, that's where the parentheses come in. We find the expression with the letters in the parentheses and use that expression with the letter on the outside. Okay, let's look at the parentheses. We have X and S with an AND gate between them. Since S and X are both false, the expression is false. Now let's use that expression for I. It has an implies left gate. Since we are simplifying the implication gates to not left or right, we can say this statement is true if I is not true or if the right statement is true. We know I is true and the right statement is false. Therefore, the entire expression is false. Let's tell the game that by toggling the red F on the right. Great, now let's do the same thing with the other one. We have the letters Q, L, and W. Q says there are exactly 2 ports. We have way more than that, so that is false. The L statement is there are more than 2 indicators. We have no indicators, so that is also false. Lastly, W asks if there are no indicators. That one is true. But don't forget the dashes on Q and W. Now Q is true and W is false. Let's look at L and W since they're in parentheses. They have an implies left gate in between. Since L is false, the entire statement is true. Now let's look at Q. It's next to a XNOR gate. Remember that the XNOR gate is the opposite of the Xor gate. Since Q is true and the right statement is true, the expression is true. And there we go, we finished the module. Now that we know how to solve the module, it's time to start planning how to code the program. I will be storing all the edge work into a BOM class, so future mods can access all the edge work if needed. Now we must get all the edge work. Let's start with the indicators. There are 11 indicators that can possibly be on the BOM, and they can either be lit or unlit. So we will need 2 Boolean variables for each indicator. The first one will be if the indicator is there or not, and the second one will be if the indicator is lit or unlit. I stored both of these booleans into a class called indicator just to keep things less cluttered, and easier to program. I will ask the user if there are any indicators on the BOM. If they say no, then I will move on to the next edge work. If they say yes, then I will ask which indicator is on the BOM and if it is lit. Next are the batteries, which is really easy out of all the edge work. All we have to do is count the number of batteries and the number of battery holders. We can have an integer for both, and just ask the user how many there are of each. Now we have to look at the serial number. This one is also easy. All we have to do is ask the user for it and store it in a string. Lastly are the ports. I made a port class that stores the name of the port, if it is visible on the BOM, and how many are on the BOM. I ask the user how many of each port are on the BOM. If there is one or more for each one, I set the visibility to true and store the number of said ports in its object. So let's see what we're supposed to have. We should have a serial number of 5K1NE2, 1 battery holder, 2 batteries, 2 DVID, 3 PS/2, 1 parallel, 1 serial, 1 RJ45, 2 stereo RCA, and no indicators. Now that we have all the edge work, we can start on working on the actual mod. I'm going to ask the user for one row at a time, and then print the answer for said row. The user will give me the expression and put parentheses when needed. Everything will be separated by a space so I can dissect the entire thing into a string array. With our top row, the array should look like this. The program will find and store the Boolean values for the letters I, X, and S, which all of them should be false. It will then evaluate the X with the S, and then use that expression in combination with the I, which should print false. Now that is done, let's test the bottom row, which should print true. With that, we have finished the program.